Hello everyone, today we're looking at a 2100 instead of a 2000 and it's 2872K. It's, I would say, pretty easy for 2100, especially in terms of thinking the algorithm. The implementation is slightly more difficult though. So yeah, the problem is really straightforward. You're given a number search in which you find expressions that's equal to the numbers that you're given. For example, on this thing, 1 plus 2 is equal to one of the numbers, which is 3. And you're given at most 100,000 numbers with a grid at most 3 times 10 to the fourth, which is 30,000 size grid. So yeah, you can pause the video and think about this yourself. Okay, so this is actually a lot easier than it looks, even though it looks really complicated and doesn't seem like it can be solved under 100 lines of code, which I mean, it didn't, it's 103, but it's actually just brute force search. Literally, you just search, except you have to keep track of a ton of stuff. In this case, you have the coordinate, obviously, the direction that we've been going, the total number so far, the multiplication number, the number that we still have to multiply if this is a multiplication, the last character, current number, and last operation, which is all explained in the comments right here. These are all straightforward. If it's out of the grid, obviously, or double operations, we have to get rid of it. And if it is an operation, however, we don't give an answer. We just keep going because we can't sum to an answer with just an operation. However, if it's a number, we have to look whether it's an addition last operation or multiplication in the last operation, which addition is much easier, but multiplication, we know the current multiplicated value is mole, so we have to subtract that from the total and then divide by what the last current, you get the idea. You have to basically renew the mole and then add it back to total, which is explained here. And then bucket is we're keeping track of how many occurrences of each number there are, and then at the end we just print the number of occurrences of the numbers that we're looking for. However, there's a minor detail in which if there's a one-digit number, it's going to be counted 7 more times than it's supposed to because we searched in all 8 directions, obviously. So yeah, it's actually a lot easier than it looks, and I just didn't consider the possibility that this could be brute forceable because it's 100, 150, 100,000, sorry. So yeah, however it is. Because if you think about it, it's the length of the operations are only at most square root of this, and the whole grid is only this. So that's obviously possible under time constraints. So yeah, thanks for watching, and I'll see you tomorrow.